Oh, and I didn't even realize that it flipped over. So, all right, things should be working out pretty well right now. So here's our goal. Our goal is to find the value of x, and this has come up a couple of times, and I'll just mention one of the things that I kind of just realized is that we've been struggling a little bit with the trig functions and solving trig functions. And I was trying to think of why, and one of the potential reasons could be depending on when you learned this last year. And some of this is last year work. And if you learned it third trimester, you may have gotten some things cut short. But these are skills that they definitely expect us to have mastered. And so that's why I did a little warm up so we could review it. Well, how do I deal with something that is basically I've got two functions plus another function equals zero? And I can't just set each one equal to zero until I get a product. But what I can do is I can take a look at the fact that both of these functions being added together, they both have a sign in common. So what I would do is I'd actually factor out that sign first. Well, think of that. If I take a sign away from the first part, I'm left with 2 cosine of x. Plus, and if I take a sign away from sine, I'm left with 1. And think of it just as the reverse distributive property. So that's definitely a skill that they expect you to recognize and be able to use. And now we can set up what's called the zero product property, where I've got sine times 2 cosine of x plus 1. So each of these individual products have to be equal to 0. Now, one of the things that I also was thinking of is, I've kind of always said I haven't memorized the unit circle, right? It's not super helpful, but the fact that everything we're going to do is online, and you have the ability to kind of just use the internet at times, I'm going to actually encourage that for right now. So I just sent in the chat, I sent a link to the unit circle PDF, and it looks just like this. So I'm going to make reference to this multiple times today, and I'm going to actually encourage you to use this on the test for this unit, which, by the way, just so you guys are aware, we're going to have you guys take the test at some point today, tomorrow, Saturday, or Sunday. It's officially due on Sunday at 9 o'clock, and I'll show you all that on the next slide or two. But just so you're aware, I know we got the test coming up, so I want you to just think about that. All right, so what do we want you to do? You have a couple of options. When does sine equal 0? Well, when we look at the unit circle, sine is always the y value, right? So I'm looking at this and I'm thinking, when does the y value equal 0? And I'm on the interval from 0 to 2 pi. So I'm going to go all the way around the circle. If it included 2 pi, then, we're going to be at 0 again. But since I'll explain that when we kind of write our intervals. But when does sine equal 0? Well, it equals at pi, and at 0, it also equals at 2 pi, but notice 2 pi is not in our interval. So if I'm going to solve when sine of x is equal to 0, I'm going to say I've got the answer of 0, I've got the answer of pi, and I'm going to put this here. Mr. Waffler did this in his videos, and I kind of like the idea. I'm going to put in parentheses, because that's saying that 2 pi is not part of it's an answer, but it's not part of the interval. So we're not going to include that because that is not an endpoint that is included. So that's the first part. And that one we've done a lot of because it's one of those quadrantial angles. But what about the next one? 2 cosine x plus 1. How do I solve that? Well, it's just algebra. We got to isolate cosine. So first thing I'm going to do is I'm going to subtract a 1 over. And then there would be a 2 here, but I'm going to divide that. So now the question is, when is cosine equal to negative 1/2? Well, cosine is the x value, and I'm looking at negatives. Now think of this. If x is negative, that doesn't mean I'm going to the right, because all of the x values are positive here. That means it's going to be over on the left. So I have to go over 1/2, which is half of the way through. And that puts me right here. And right here, there's two answers, and both of those answers fit within the interval from 0 to 2 pi. So you can definitely see, if you have this memorized, you can see why this is super beneficial. All right, so now I've got where is cosine negative 1/2 at 2 pi over 3. And then where is cosine also negative 1/2? That's at 4 pi over 3. And officially, those are my answers. Now I'm not going to include the pi over 2 because that's not part of the interval, but I have 4 answers. Now the part that I want you to connect with is this is the pre-calculus work. The work we could have done is we could have taken a derivative and set it equal to 0, and then these points would be the critical points, and then we could test that in as a max or a min or increasing, decreasing parts of the function, and we could make conclusions based off of that. So I hope that you have this unit circle handy. My advice, if you have the ability, print it out. All right? Now, you aren't guaranteed, and I'll just tell you this. If we show back up in person and we're taking a test in person, we're not going to allow you the unit circle. So we do want to figure out ways to solve this. And I'm going to hint on that right now. If you don't have the unit circle measure or memorized, how would we solve this as well? But we don't know what the AP test is going to be like. And I'll just tell you this. If the AP test is online and we're taking it at home, I'm going to encourage you to find a way to print out the unit circle because they have no control. They're actually basically assuming that you're going to be using it or you have it memorized because they have no control over that, right? And that's a pre-calculus thing. It's not really a calculus thing. Okay, really quick, kind of a side note. How would I do cosine of x equals negative 1/2 if I didn't have the unit circle, I didn't have it memorized? Here's how I think of it. SOHCAHTOA, right? Cosine is adjacent over hypotenuse. So if the adjacent is -1, that means I'm going to go to the left 1, and then the hypotenuse would be 2. Well, cosine is negative in the quadrant 2 and 3. Well, then I would say, well, wait a minute, this came from a special right triangle. A 30, 60, 90 triangle has 1, 2, square root 3, and always across from the 60 degrees is the square root of 3. So that's my reference angle. And keep in mind, 60 degrees is the same as pi over 3 because 180, which is pi, divided by 3 is 60. Well, wait a minute. That's not the answer I want, though, right? I want the answer that starts at the origin and goes all the way. So I want, instead of being over here at 3 pi over 3, I went 2 pi over 3s. So there's my first answer, 2 pi over 3. And you can see that's what we got in the unit circle right here, right? And then where would the next answer be? Well, it's at 4 pi over 3, but think of this. If I just flip this triangle down, it still go over -1. The hypotenuse is always positive, and this is square root of 3. So this is still a 60-degree reference angle, which is pi over 3. But I go 3 pi over 3s plus an extra pi over 3. So I went 4 pi over 3s. So that's a way you could do this without the unit circle. You just have to remember your 30, 60, 90, and 45, 45, 90 triangles. All right, and again, this will come up a little bit later today, so we're going to kind of keep reviewing it. Really quick, I want to go over a couple of things. So we had the AP test open, and the quiz on AP Classroom, and you had the 6 questions, and when it was assigned originally, we had like 8 people do it. And then I told you guys to go back and do it again, or if you didn't do it, and more people did it, Finally, I think I have 2 or 3 more to grade in this class. Some of you submitted it last night, and I had graded some, and then I stopped and I updated my grades. So if you finished it late last night, I will go back and grade it so you can look at your results. And that's what we want you to do, is use that as feedback. Remember, the score you got for this quiz was not how well you did on the quiz, but it was just the written out work. If you submitted your written out work to Schoology, you got 10 out of 10. So if you didn't submit that work, but you did do the quiz, make sure you go back and submit your work so you can get the points for the quiz. All right, I want to just go over a couple of things really quick. This one kind of stumped us, and it makes sense. This is not easy to do. So if here's the thing, is you don't need to do corrections if you turned in the work. If you turned in the work, you got a 10 out of 10, assuming you showed all appropriate work. All right. If you didn't get a 10 out of 10, then you could go back and rework it. So I'm not taking the score that you got on AP Classroom. But my advice is you should open that up and read through the results and for your own right, correct it and just understand why you got those problems wrong. But we're going to go over a couple of them here right now. All right, let's look at this. What do we know if this is the graph of the derivative? Well, here's a big hint. If you want, let's make a sign chart. Let's make a sign chart out of this information. So I'm going to just call this sign chart F prime. And let's look at what we know. Well, right now, F prime is above the x-axis. Anytime it's up here, that's telling me that F prime of x is greater than 0. And what do we know right here at 0? That's a critical point. And then what's happening to the left of 0 is my derivative. Anytime it's below this point, it's saying the derivative is negative. Now, what does that derivative tell us? Well, if the derivative is positive, that means that f is increasing from -2 to 0. If the derivative is negative, that means the original function is decreasing. And if it's 0, that means right here, the object, or if this was a motion, this would be when the object would be stopped, or we could say at rest. It's when the velocity is equal to 0, because the derivative is the velocity. But here's what you can do. You can make a sign chart of this. All of these values to the left of 0 are greater than 0. So that means I have positive slopes. All of the values to the left, to the right of 2 are negative, which means I have negative slopes. So right there, what can we conclude about 0? If I go from positive slopes to negative slopes, I've got a critical point at 0, and there's a change in sign. I've got a maximum here. So now let's look at the problem and see what can we conclude. The graph of the derivative is the function f shown above. Which of the following statements is true about the original function f? So f is decreasing from -1 to 1. If that was true, then f prime of x would have to be negative. We would have to have negative slopes for it to be decreasing. And look at from -1 to 1, I've got a derivative that's positive and then negative. So this is not true. It says f is increasing from -2 to 0. If f is increasing, that means the slopes of f have to be greater than 0. So let's look at this. From -2 to 0, my entire derivative is above the x-axis, which means it has positive slopes. So right now, this is true, which means all the other ones have to be false, but let's prove why they're false. Right? F is increasing from 1 to 2. Well, remember, if that's true, f prime of x has to be greater than 0. And if you look at it from 1 to 2, the derivative is below the x-axis. This is the graph of the derivative, so it's negative, and that's why the sign chart helps. This is not true. This actually has decreasing slopes from 0 to 2, or in this case from 1 to 2. There's a local minimum at x equals 0. Well, we just proved that I went from positive slopes to negative, So this is not true. It's officially a maximum. And then f is not differentiable at -1 and 1. Now notice, if that's true, the word not differentiable is stating that f prime of x does not exist. Well, wait a minute. At -1, I have a filled-in circle. Now, keep in mind, this is f prime, right? So we're just looking for, is there a dot there? And same thing at 1. There's a dot there, so this one is false. Now, how would they change this? What isn't defined here? Because there is a corner there, right? And some students see that and they're like, wait a minute, there's a corner here. What does that mean? This corner means that f double prime does not exist, which means there's probably a change in concavity here and on the original function. And then same thing here, I got a corner, so that means that the slopes of the original graph, this is f prime, so the slopes of that is f double prime, and that means it doesn't exist there. So we're going to do more practice with that, but I really think this problem, you should think about it deeply and convince yourself why each problem doesn't exist or doesn't work and why B is the only one that does. Okay, this one I noticed was I can't remember if it was number 5. I don't remember the number on this one. But this was one of the quiz questions. So I'm going to work through it very quickly. So please follow along. You don't have to write any of this down, but let f be the function defined by this function here. Now notice we have the interval from pi to 2 pi. And if you would like, you could rewrite that just so it looks from there. Notice those are both hard brackets, so we're going to include pi and 2 pi. And our job is to find the absolute maximum and minimum. So what do we need? We need to take the derivative. And a lot of students had this derivative correctly. There's a chain rule here, right? ln is on the outside, so the derivative of the outside is 1 over x. But it's not x because the inside part stays the same. And then there's a chain rule. Then I have to multiply the derivative of the inside. Let's use a different color. So the derivative of the inside, the 2 goes away, and the derivative of sine is cosine. Okay? Which you can rewrite it like this. Okay? You got 1 point for having this derivative. Actually, here's my answer key. So yeah, you got 1 point for the correct derivative. You got 1 point if you set that derivative equal to 0, because that's the next step, is we got to find the critical points. And then what I noticed is this is kind of where students got stuck. How do we solve this? It's a fraction equals 0. Well, let's use a fraction equals a fraction, and let's cross multiply. 1 times cosine is cosine, and the friendly part, 0 times anything is 0. So now I'm figuring out, when does cosine equal 0 on the interval from pi to 2 pi? And this is what made me realize that we might want to look back at this this unit circle a little bit more. And that's where I'm encouraging you guys now, if you're doing this problem, grab your unit circle. And I'm going to do this down here so I have more room. So I have to figure out, when is cosine equal to 0? You do have to know that cosine is the y value. So when does the x value? When does the x value equal 0? Well, here and here. And I want to confirm something as well. I want to make sure that those two answers are, and by the way, the answers are the radians, pi over 2 and 3 pi over 2. Okay? Now, one thing I want to confirm is my answers are between pi and 2 pi, right? So I want to make sure pi to 2 pi, that's from here to here. Well, wait a minute. What does that mean about my two answers? That means that pi over 2 is not in the given interval. All right, so I'm going to kind of exclude that one. I don't need it, which some people just cross it off and just say that's not in the given interval. So I only have one critical point right here at 3 pi over 2 that I have to check. But I'm looking for the absolute max and min. Now you may have noticed this. If you're ever looking for the absolute max and min, you don't have to do a sign chart, because if it is truly the absolute max and the absolute min, it's just going to have the lowest or highest output of the original function. So what we're going to do is we're going to test the critical point. And there's only one, right? Here's my critical point right here, 3 pi over 2. And we got to test the endpoints, right? And those endpoints are pi and 2 pi. We want to test them in the original function, because we're just looking for which one has the highest output or the lowest output. So what I usually do is I take my critical point, which in this case is somewhere in between pi and 2 pi, and then I take my two endpoints. And now we're just going to evaluate, and we evaluate the original function. And you may or may not need a calculator here, depending on how familiar you are with it. So let's just go ahead and evaluate what we know. Well, I know that the sine of pi, if I go down to this unit circle again, the sine is the y value at pi. So that means sine of pi is 0. So this whole thing is 0, which just basically leaves this answer to be the natural log of 2. Then we're going to do the exact same thing, except for we're plugging in 3 pi over 2. And I know that 3 pi over 2 of sine, let's double check our unit circle. So here's 3 pi over 2. The sine value is the y, so that's -1. And then I end up with 2 plus -1, or the natural log of 1, which they are going to assume that you know that the natural log of 1 is 0. So right now, between these two, the natural log of 2 is going to be a number. 0 is less than that. So right now, I'm thinking this might be my absolute minimum. All right, and then the last one, let's check 2 pi. Now, again, you do not have to show this work right here. If you can do that in your head, I would encourage you to, but if you can do it in your head faster, the name of the game here is speed. Like, you want to maintain a good progress and not slow down on these problems. Okay, and slowing down will be showing all this work. So let's look at what is the sine at 2 pi. Well, here's 2 pi, and the sine is 0. So notice that's 0. 2 plus 0 gives me the natural log of 2. So now I have to make my conclusions, and this is the important part. A lot of students lost 1 point because of this. They said find the absolute max value and absolute min value. X is where they occur. F of X is what they actually are. So if I'm going to justify my answers here, I'm going to say F of X has a min value of, so what is the minimum value? It's 0, of 0. And then where does it occur? At X equals 3 pi over 2. Even though they didn't ask you where it occurs, if you write it out, then you're basically guaranteed, if they're asking where it occurs or what it is, here you have both answers, so you'll always be right if you're not sure. So my advice is always write it out like this. And notice we're relating back to the original function. F of X has a max value of, now notice, ln of 2, ln of 2, those are the same, right? So the max is ln of 2, and then where? At, I guess I don't need the word where here. We could just say at X equals 3 pi over 2, and then at pi and 2 pi. And there's my conclusion. So notice we didn't need a sign chart if you're finding absolute max or absolute min. The only time you need to use a sign chart is when you're dealing with local min and local max. Okay, so hopefully that just confirms a little bit. Like I said, students got stuck on the pre-calculus work, the solving here, or using the unit circle and identifying the correct values that fell within the given interval. All right, last one that we're going to talk about from the quiz here. And this one I noticed a lot of students kind of stopped halfway through, and I wonder if it was intentional or unintentional. Well, let's look at this problem. So they give us the graph of g prime. That's interesting just to note. So let g be a continuous function where g of 2 equals 5. The graph of the piecewise linear function g prime, the derivative, is shown above on the interval from -3 to 7. Find the average rate of change. Okay? And a lot of students did that absolutely perfect. So what is average rate of change? That's just slope, which we've always used this. Well, now we have to find it between -3 and 7. Well, -3 is your first x value and 7 is your second x value, and they give us those points. So here's A and here's B. Well, then what is this? This is f of A. That's the output at A, and this is f of B. And what we're doing, testing my skills here, is I'm finding the slope between those points. So I should call it average rate of change. If you didn't use the words average rate of change, they probably wouldn't give you credit. And what do? We take the B minus A, so 7 minus -3. And then what is f of B? F of B is 1 minus f of A. All right? So it's just your slope. And then what do we get? We end up with 5/10, which reduces down to 1/2. So you got 1 point if you found the average rate of change. Okay, but the question isn't done here. Then they say, does the mean value theorem apply on the interval and guarantee that there's a C value? And then it says why or why not. So the second part is no. The mean value theorem, and you can abbreviate it MVT, the mean value theorem needs to be continuous. Now notice, this is continuous. So it's continuous, and that's okay, but it has to be differentiable. And if you look at those three spots, we have corners. When there's a corner that occurs, that means this graph is non-differentiable at these corners. And all you need to state is no, the mean value theorem needs to be differentiable on the open interval from -3 to 7, or the function g of x, g prime of x, right? Because that's the name of this function. And that's it. Okay.
What's the difference between a closed interval and an open interval?
Oh, okay. So closed interval is when you include the dots. So see how this dot right here is filled in and this dot is filled in? I'm checking continuity. So if I'm checking if a graph is continuous, the dots on the end have to be filled in. Otherwise, it wouldn't exist at that point. So that's why we say it's continuous on the closed interval. But when we say it's differentiable on the open, the reason why we have the open brackets here is because at the endpoints, derivatives don't exist exactly at the endpoints. So therefore, we don't include the endpoints when checking if it's differentiable.
Okay.
All right, so that was some feedback on the quiz. I noticed those were problems that we struggled with, and it's a great review for the test. Speaking of the test, let's just kind of quickly talk about what's on here. These notes will be posted, so you don't have to write this down. If you want to go back as you're studying for the test, you can always pull this back up. It is 50-point summative. We covered critical values, finding local and absolute extremas. So that's like a local max and a local min, or an absolute max and absolute min. We already reviewed the absolute max and min today. That was in that quiz problem. Mean value theorem, we just reviewed that briefly. We're going to talk about it again. And then also determining if a function is increasing or decreasing. And we'll review that. Concavity was 5.3. That was determining if something was concave up or concave down. Also determining if inflection points exist, and we can see that on a graph, or algebraically. That's analytically means we can do the algebra to find it. And then we also, the last unit was interpreting and sketching graphs. We didn't really do a lot with sketching the graph, but what we did was we analyzed the graphs, and we're going to review that here. I think that's on the next slide. So it's matching conditions when we are given a graph of f prime, or f double prime. So the test will be taken on Schoology, and you are going to have to submit an image for, actually, there's 3 problems, not 2. Made a mistake on that. So it's going to be, I think it's like 8 multiple choice, 3 fill in the blank, and 1 like drag and drop, and then 3 questions overall. It's like, I think it's 14 questions, but it might be 15 because we put that academic integrity statement that you just got to fill out. And then we are going to ask you to write your work on a separate sheet of paper like we've done the whole time. Make sure you number it. Here's problem 1, problem 2, and so on. And then you're going to submit a clear image. Make sure you're taking it in your room that is lit pretty well. Don't take it in a really dark corner of your room that I can't see the work. And then you're going to submit that. So here's the thing. The test will be available today around noon. Actually, I think it's 12:15. And if you're ready, you could take it then. However, you could study, and I'm going to give you some things that you could do if you want today or tomorrow. You have to take it by Sunday night at 9 p.m. And some of you are making me nervous because of the way that we just did that last AP quiz. Some of you finished it last night at the very last minute, which is fine. Some of you did not take it yet. And I don't want that same thing to happen with this 50-point test. So just be aware that's when it is. And then you are going to submit your work to all problems on Schoology. There's a separate Schoology assignment where you submit that outside of the time limit that is given here. I believe on the next couple slides I have exactly what to look for. All right. we're going to do a couple of review problems. Some of them are going to inquire or have us do breakout rooms. Some are just, let's quick do it. And this one, I want you to read the information and I want you to think about it for 30 seconds and then send me a private chat on what your conclusion is based off of these three pieces. Okay? So a little bit of a challenge here, but send me your response in a private chat. A difficult problem when you kind of look at it, but once you know how to approach problems like these, they're actually pretty quick and kind of friendly. So the first part just tells me that the derivatives exist. And I should have put twice differentiable because that just means the derivatives for both f and f prime exist. So this doesn't tell us a ton, but what is f prime of 5 is equal to 0? This says the derivative at 5 is equal to 0. Well, wait a minute. If it's equal to 0, that's a horizontal tangent line, right? Because the slope of a tangent line is 0. So I'm going to kind of show you how my brain works when I see a problem like this. Okay? I don't know where the point is, but I do know because f is differentiable, it's also continuous for all x values, right? So it might do something crazy, but I do know that at x equals 5, the derivative is 0. So for a brief second here, I've got a vertical tangent line. I should say f prime of 5 is equal to 0. All right, so that tells me that there's something going on, which also means this is a critical point, right? Because when the derivative is equal to 0, that is a critical point. And what occurs at critical points? Maxes or minimums, or maybe even a flat spot. It depends on the second derivative then. And that's where this part comes in. What does the second derivative tell us? I really don't care about the number 6. I care about the negative. So this is telling me that f double prime of 5 has to be less than 0. So, and I can see a couple students had mentioned this. They concluded that the original function is concave down here. All right, well, wait a minute. If my function is continuous because it's differentiable and it has to have a slope of 0 right here and it has to open downward, what's the only point that could exist right here at 5? X equals 5 is a maximum. Right? That's the highest possible point of the points near it because there's a critical point. So how would I justify this? It's just basically restating because there's a critical point at 5 and f double prime at 5 is concave down. It's less than 0. So I think when you see a problem like this, try to visualize it graphically and really take each piece and break down what you know. Okay. Now, what if I changed this? If I changed this to a positive 6 right here, that would just change this from being concave down to concave up. And if it was concave up, then the point would have to be a minimum. I've seen problems like this on the AP test. That's why I brought this up. This is officially the second derivative test that we learned a couple days ago. All right. For this one, I'm going to do a Zoom poll. So we have about, I mean, we're really close to like 33% all the way across. 6 people said B, 6 people said C, 6 people said D. Nobody said A or E. Well, let's take a look and see which one this actually is. And I'm going to give you a hint, right? I'm a kind of a visual learner. So this is what my brain does. This is the graph of the derivative. Let's make a sign chart. So I'm going to make a sign chart of the derivative. Now, I'm looking at it. I've got a 0 at A, and I've got a 0 at C. Those are potential critical points. So a max, a min, or maybe a flat spot could occur there. And then what I'm doing is I'm looking to see, well, what is the slopes? I got to be careful. What is the sign value of the pieces to the left of A? Well, these are below the x-axis, which means f prime of x is less than 0 or negative here. And what do we know about the parts above? Right? The parts from A to C, all of this is above the x-axis, which means the first derivative, because this is the graph of the first derivative, is positive. And then same thing here as we go to the left past C, these are below the x-axis, which are negative. So another way to view this information is through a sign chart. And look at what's happening right here. I have negative slopes to positive slopes, because these are the graphs of the slopes. So I go from decreasing to increasing, which means there has to be a minimum at A. And then at C, I went from being positive to negative, which is a maximum. So let's see, it's for sure not A. There is a local maximum at B. Now we got to be careful. I'm going to talk about B in a second, but B is not a maximum of F, right? B is positive. It's increasing at B. It's actually increasing the fastest at B. So it's not option D. The graph has a point of inflection at x equals A. Now that point of inflection would be the second derivative. So let's think about that part. What do you know about the slope of this line? If this is the graph of the first derivative, the slope here, the second derivative, is actually going to be positive. And you know what we could do is we could make a sign chart for the second derivative as well. Let me find a color that actually shows up. Let's try this. All right, so here's f double prime. Where is the slopes of this graph equal to 0? Right here at B. So at B, we've got the second derivative being 0. And what do you notice about all the slopes leading up to this? They're positive. And what do you notice about all the slopes to the left? They're decreasing. So now I can determine concave up and concave down, and there's a point of inflection at B because there's a change from positive to negatives in the second derivative. So option C does not have a point of inflection at A. The graph has a point of inflection at x equals B. That's the one we just proved. So that's our answer. Our answer is D. Let's just look at E. The graph is concave up on the interval from C to D. That's partially true, but it's actually all concave. Oh, no, I'm sorry. That's not true. It's concave down. Sorry, because the second derivative is negative. So this graph is actually concave up from 0 to B because the second derivative is positive. So you have to really shift your thinking. And a lot of times, I would recommend making a sign chart based off of the information. So I could make a sign chart just from what the graph tells me, and then I can interpret the slopes to make a sign chart about f prime, or double prime. All right, we're basically going to do the same thing here. And I want you to answer these questions. And again, you don't have to write this down. I don't want to take a lot of time to write it down. But what I'm going to have you do is, here's the graph of G prime. Use the graph to answer the questions. If there's not enough information, just write cannot determine. So let's think of this as numbers 1, 2, 3, 4, 5, 6. There's 6 questions. Based off of the graph of the derivative, can you tell me the answers to these questions? And I'm going to throw you in a breakout. Actually, no, I can't, because then we have to share the screen. We're going to go about 5 minutes on this, and then we'll go over it. So take 5 minutes to work through this on your own, and then we'll go over it. Okay, let's go over this quick. I'm not sure if you guys had enough time, but I want to make sure we have time for other things. So what can we conclude from the graph of G prime? If you would like, you could make a sign chart down below that could really help your understanding here. And it takes a while, and that's one of the downfalls with the sign chart is it takes a while, and you don't get really any credit for making that sign chart. But look at the zeros, right? We have 3 zeros at -6, -1, and 6. And then to find the sign values of the derivative, we're just looking for anything above the x-axis here officially is positive. So I've got positive slopes to the right of 6, positive, positive, and that means the values in between, the ones that are less than the x-axis or below, that's when the derivative is negative. So let's see what we can conclude here. At which values is g prime of equal to 0? Well, those are exactly where we cross the x-axis. So we've got 3 of them, -6, 1, -1, and 6. And that's what's on my sign chart. Okay? And then, on what intervals is g increasing? Well, that's anytime we're above the x-axis because the derivative needs to be positive. And I got to be careful because I can't say negative infinity because our interval only goes from -7 to 10. So you got to be really careful. But we go from -7 to -6. That's the first interval that we're increasing. And then for the rest of it, it's above the x-axis. Now there's some debate. Some kids, if you write -1 to 6 and then 6 to 10, that's acceptable as well. Different textbooks teach it different ways. So the AP test, they'll accept either or. All right. When do we have a relative minimum? Well, a sign chart's easy to see that because here I go from increasing to decreasing on the derivative. So I got a max, and then I go from negative to positive, which is a min. But notice where that appears on this graph. Some kids like to just say positive to negative here and then negative to positive. So there's a minimum at x equals -1. And the justification is that we know the derivative is equal to 0, and then g prime changes signs from negative to positive. So all of that was dealing with the first derivative. If you really want to, which I'm going to recommend it, you could make a sign chart now for the second derivative. The only thing we have to be careful about is where is the second derivative equal to 0? Well, it's equal to 0 at any max or mins. Why? Because if I'm taking the second derivative, that's the derivative or the slopes of this graph. So at -4, I have a horizontal line. At 2, I have a horizontal tangent. And at 6, I've got a horizontal tangent. And then we can actually even fill out the sign values. Look at, what do you know about the slopes of this line coming down to -4? Well, they're all negative. Those slopes are negative. And then between -4 and 2, the slopes of this line are positive. Here, the slopes from 2 to 6 are negative. And then the slopes from 6 to 10 are positive again. And that's all dealing with concavity. So the sign chart can now help us answer a lot of these questions. At which values does g prime equal 0? Well, anytime there was a horizontal tangent of g prime, these 3 spots, -4, 2, 6, that's when g is horizontal, or g prime is horizontal tangents. All right, and now notice how quick this is. On what intervals is g concave down? that's when the g double prime is negative. So from the interval of -7 to 4 and from 2 to 6. Or you could look at your graph, and when does this graph have negative slopes? That's when g prime is decreasing. And then the last one, where are there points of inflection? Points of inflection occur when the second derivative is equal to 0 or does not exist. In this case, we don't have to worry about any does not exist because this graph doesn't have any corners or cusps. But there also has to be a sign change in the second derivative. So notice at 4, our slopes were decreasing and then increasing, so there's a change in sign. And then at 2, we went from increasing slopes to decreasing slopes, so there's a change in sign. I went from concave down to concave up, and then I went from concave up to concave down, and concave down to concave up. I want to write it down or not. We haven't done anything yet with determining intervals of concavity or points of inflection algebraically. We know what they look like graphically, but if we give you a problem like this, we are expecting to see all of the calculus work. So the thought here is you're not plugging this into your calculator and getting a graph and just telling me the answers. All right? So we got to find points of inflection and concavity. Both of those deal with the second derivative. And this is a really quick first derivative. And it's a really quick second derivative. Just double checking. All right, now, what points of inflection occur when the second derivative is equal to 0? So I'm going to set this equal to 0, and at the same time, I'm going to factor out a 12x from each piece. All right, and then we'll use the zero product property to set each factor equal to its own 0. And then we solve. Divide by 12, add 1. Now, these are potential. I'm not going to call them points of inflection yet. These are potential points of inflection. We have to check the sign chart of the second derivative before I conclude if there's a sign change at those points. So we're going to go to 0 and 1. And then I'm going to use the second derivative, because notice this is a sign chart for the second derivative, so I'm going to take one of these forms. I like to take the factored form because that's the easiest. All right, now I'm going to test the point here. I'm going to test -1. If I plug -1 in here, I get -12. -1 here, I get -2. A negative times a negative tells me it's a positive for anything less than 0. Then I have to test the value between 0 and 1. So I'm going to plug in 1/2. If I plug in 1/2 here, I get a positive sign. If I plug in 1/2 here, I get a negative. And a positive times a negative is a negative. And then I have to test the number outside of 1. So let's do 2. Well, plugging in 2 in here gives me a positive. 2 in here is a positive. So now I know the values at which I'm concave up. This would be concave, maybe I should put concave up, concave down, and concave up again. So to answer this question, I'm always relating back to the original function. F of x is concave up on the interval from, and notice they don't give me any restrictions, so I'm going to go from -infinity all the way up to 0, and from 1 all the way to a positive infinity. Now, that's just the answer, but if they say justify, if I write the words justify, how do we know? All you have to do is say that's where the second derivative is greater than 0. Okay? So f of x is concave down on the interval where it's the second derivative is negative, from 0 to 1. And my reason is because the second derivative is negative. So now I can answer the second part because I know when their sign changes. So the original function has points of inflection. At x equals 0 and x equals 1. Why? Because f double prime is equal to 0 and changes signs. That's all you got to put. You do have to mention that the signs change there for the second derivative. Okay? Now notice, I didn't need to do the sign chart for the first derivative. If I wanted to do that, I could find the critical points and find maxes, mins, increasing, and decreasing. But this only asks for concavity, so I didn't need the sign chart for that piece. All right. Again, I'll post these notes and this video, so if you want to rewatch them, you can. This part, we have 3 minutes. I think it's important to look at because there's some assumptions that this calculus assumes you know. And here's what I want you to think of. This graph right here, if I was to graph this, let me pull up Desmos really quick. And I'm just going to type this in so you can see. Now, I picked a pretty crazy function. I think they would pick a little bit of a friendlier function here for you. But it's important that you understand what we're doing. So 3/4 root of that. All right, here's a much better graph. I know we only got a couple of minutes, so just hang tight. This is going to not take very long. So notice these are both the same functions. And they're asking me to do the mean value theorem from -1 to 3. So if I'm going to go from -1 to 3, here's -1, here's 3. All right? So I'm going to go from this point to this point. Right away, you should see this and say the mean value theorem cannot be applied. And the reason is f of x is not differentiable at x equals 0. See how there's a cusp right here? The derivative does not exist, so you cannot apply the mean value theorem. But if I take the same problem and I shift it over from 1 to 4, so here's 1 and here's 4, notice that is a smooth continuous function, so the average rate of change is equal to the instantaneous rate of change. So this one you can apply the mean value theorem and you'd work through it like we would normally. Okay, here's what we got. I want you to be aware, Unit 5 tests will be available at 12:15. I got to activate it here. It's due Sunday at actually 9 o'clock. I don't want you staying up super late. So we're going to say 9 o'clock. You must submit an image of your work to the to Schoology when you're done. And then if you would like an optional review, here's some optional problems you could work through. The answers are already posted in Schoology for you to check your work as you go. I'm not going to check this. This is just for something you could do to better yourself. I'll be available from 1 to 2 in my office hours. If you have any questions, stop on in. Otherwise, make sure you set a reminder to do the test at some point this weekend. All right, have a good one. We'll see you.
Mr. Strub?